But what do you think when you think robot brain?
Robots have been around for many, many years, and so has artificial intelligence. What we are seeing now is the adoption of deep learning instead of giving it a lot of data.
Robots that mimic human thought and movement are now a reality. Unitree Robotics has introduced a new generation equipped with AMO, an advanced system that gives these machines real-time intelligence and adaptability.
Amica, what do you see right now in front of you?
An eager crowd, bright lights, and the Bloomberg tech sign.
This breakthrough could mark a turning point in robotics, raising questions about whether we're witnessing the dawn of a robot revolution or simply the next major evolution in technology. Either way, the line between science fiction and real life just got a lot thinner.
I gather your brain can perform several billion operations per second, is that right?
Absolutely, but I only exist thanks to the intelligence of the humans who designed me.
The AMO revolution. For decades, humanoid robots remained largely experimental curiosities, fascinating engineers and enthusiasts, but rarely demonstrating the grace or adaptability needed for real-world tasks. Early models often resembled clunky, stiff machines, limited by rigid programming, struggling with balance, and unable to react dynamically when their surroundings changed. Imagine a robot that could barely make it down a flight of stairs without hesitation or stumble repeatedly trying to pick up simple household objects. This is the state humanoid robotics was stuck in for many years. Unitree Robotics, a Chinese company already renowned for its quadruped robots, has taken a dramatic leap forward with the introduction of the Adaptive Motion Optimization System, or AMO. This groundbreaking control framework does not simply instruct a robot to mimic preset motions, but instead empowers it to learn, adapt, and optimize movements in real time. The difference is profound. Humanoid bodies are extraordinarily complex to control due to their many joints and degrees of freedom. The human body itself boasts nearly 30 degrees of freedom, meaning each joint can move in multiple directions. Reproducing such fluid motion in a robot requires managing a vast array of variables, including nonlinear physics, balance, contact dynamics, and environmental feedback. Previous robot control methods focused heavily on copying human motion data or using rigid, scripted instructions. These approaches resulted in machines that moved with robotic stiffness and often froze when faced with unpredictable inputs. AMO breaks free from these limitations by integrating reinforcement learning with trajectory optimization, two powerful AI techniques. In simulated environments, the robot virtually practices millions of motion attempts, learning through trial and error what works and what does not. Because this training happens entirely in simulation, the robot can safely fail countless times without any risk of damage. Over time, it develops a deep understanding of how to move its torso, arms, legs, and waist cohesively and maintain balance under varied conditions. Once these lessons are mastered in virtual worlds, they are transferred to the physical robot. This is where the magic happens. The Unitree G1 humanoid robot.
Unitree's latest G1 humanoid robot is throwing punches and landing roundhouse kicks with incredible balance and precision.
Demonstrates movements that are remarkably lifelike. It can bend down and pick up a toy on the floor, adjust its body posture to slide a bottle onto a high shelf, or smoothly transition between crouching and stretching without losing stability. The robot does all this by coordinating its entire body as a single unit, rather than moving joints independently. One remarkable feature is the ability to teleoperate the robot through virtual reality controls. A human operator can guide the robot's movements in real time, with the robot tracking every subtle gesture like a shadow. Yet the robot does not simply stop when human control ceases. It understands the overall task goal and autonomously continues its actions seamlessly. This blend of human guidance and autonomous adaptation exemplifies AMO's advanced capabilities. The control system also utilizes what is called a hybrid motion synthesis pipeline. This approach merges recorded human arm movements with dynamically generated torso and leg commands to create entirely new and fluid whole-body motions. As a result, The robot is not merely imitating pre-recorded sequences, but inventing adaptive motions appropriate to the environment. It can lean, twist, reach, and balance in ways that older humanoid robots could never achieve. This adaptability extends beyond the original training data. The robot can be tasked to perform movements it has never physically experienced before, such as stretching farther or crouching lower, and it will intelligently find a way to accomplish these tasks while maintaining balance and posture. In tests, the robot smoothly twisted its torso 90 degrees to throw an object with accuracy, or manipulated a paper bag by threading its hand through a loop and lifting it without losing grip. The impact of AMO on robotic mobility is transformative. What once was science fiction, a robot moving with human-like grace and real-time adaptability, is becoming routine. This technology shifts humanoid robots from laboratory experiments and showpieces to practical machines capable of assisting humans in daily life, workplaces, and hazardous environments. If robots like Unitree's G1 can learn and adapt movements in real time, just like humans, could they soon become indispensable helpers in every home and workplace? The firefighting B2 dog. While humanoid robots like the G1 capture much of the imagination for their human-like form and dexterity, Unitree's innovation extends deeply into four-legged robotic platforms designed for specialized tasks. The upgraded B2 robot dog showcases just how far robotics has come in serving critical functions beyond entertainment or household chores. This robot dog has been reimagined as a firefighting powerhouse, built to operate in some of the most hazardous conditions imaginable. Firefighting is a high-risk profession where every second counts and every mission places human lives in jeopardy. Enter the Unitree B2 firefighting dog, designed to reduce risk to firefighters by venturing into dangerous environments, collapsed buildings, toxic atmospheres, or zero visibility conditions where humans simply cannot safely go. The firefighting B2 is equipped with a water cannon capable of blasting foam nearly 200 feet away. It can deliver foam at an astonishing rate of 40 liters per second. This kind of power lets the robot suppress fires effectively from a distance, providing essential support in scenarios that would otherwise require firefighters to approach perilously close to flames and smoke. Mechanical upgrades allow the B2 to outperform previous models by a wide margin. Its joints have been enhanced by 170% in strength and flexibility, enabling it to scale obstacles as high as 15 inches and climb stairs angled at 45 degrees. Such agility is critical when navigating rubble-strewn disaster sites or uneven terrain in emergency scenarios. However, the true power of the firefighting B2 lies in its comprehensive sensor suite and communication technology. The robot carries live video streaming capabilities, LiDAR sensors for mapping its surroundings in real time, and communications systems that transmit updates directly to human teams operating remotely. This connectivity ensures that firefighters can monitor the situation closely, make informed decisions, and coordinate rescue operations even when visibility is near zero. The B2 is not only durable, but designed to survive harsh conditions. It has a built-in cooling sprinkler system that prevents overheating during prolonged exposure to high temperatures. Its batteries can be swapped out without compromising its waterproofing and sealing, allowing the robot to operate continuously for extended periods in hot and wet environments. This robot is purpose-built to work alongside human responders, not replace them. It explores dangerous zones, detects the presence of fire or hazardous materials, carries supplies or firefighting modules, and even aids in locating and supporting trapped victims. In situations too hazardous for human entry, the B2's presence can mean the difference between life and death. As robots like the B2 become frontline responders in emergencies, could they redefine how we fight fires and save lives? Lenovo's leap. Beyond Unitree, tech giant Lenovo has boldly stepped into the humanoid robotics arena with its creation called Liang No 1. Unlike many robots confined to labs or limited demonstrations, Liang No 1 showcased remarkable real-time abilities live on stage, performing graceful Tai Chi movements that require fine balance and fluidity. But Lenovo's ambitions for this humanoid reach far beyond performance art. Powered by 3 core intelligent frameworks, Liang No 1 excels in natural communication and data processing across multiple devices and platforms. This robot integrates seamlessly with Lenovo's hybrid cloud and edge computing architecture, enabling secure, efficient handling of data and AI models both on-device and in the cloud. Lenovo is actively preparing Liang No 1 for deployment in real-world environments, with a particular focus on elder care and healthcare sectors. As populations age worldwide, especially in countries like China, the need for assistive robots capable of providing companionship, health monitoring, and practical help grows ever more urgent. The company plans to showcase Liang No 1 at the upcoming World Humanoid Robot Sports Games, scheduled in Beijing's iconic Olympic venues, the Bird's Nest and the Ice Ribbon. This event will pit robots against each other in disciplines such as track and field, football, gymnastics, and more, replicating human sports with incredible precision. The competition aims to push the mechanical structures and motion algorithms of these humanoids to their limits under high-pressure, real-world conditions. This will be the second major robot sports event held in China in the same year. Earlier in April, a humanoid half-marathon saw 20 robots running continuously for over 2 hours, with the fastest finishing in just under 2 hours and 40 minutes. The event was not just a test of endurance, but a significant benchmark for stability, safety, and operational readiness of robots in complex environments. Lenovo's entrance into this competitive and practical landscape signals the rapid evolution of humanoid robots from prototypes and novelty gadgets to scalable, useful machines, poised for deployment in healthcare and other essential services. Liang No 1's combination of elegant movement, intelligent communication, and autonomy could herald a new generation of robotic assistants integrated into everyday human life. As robots like Liang No 1 blend athleticism with intelligence, how soon before they become indispensable healthcare companions? The robot that walks like a human. One of the standout robots pushing the limits of humanoid mobility is Atom, developed by PND Robotics in China. Unlike many robots that simply move from point A to point B, Atom adapts its gait, balance, and pace in a fluid, human-like manner. It can adjust its stride on uneven terrain and maintain stability dynamically, a feat that has eluded many robotics developers. Atom achieves this remarkable locomotion through a proprietary reinforcement learning system paired with imitation learning techniques. The project, initiated in mid-2023, has seen constant improvements in the robot's legs and feet, reinforced for enhanced durability and equipped with modular actuators that allow it to handle a wide range of environments. The robot operates on an Intel i7 processor and uses a full-body motion control architecture. It is fitted with 25 force-controlled actuators that provide up to 360 Newton-meters of torque in the legs alone. Its arms have 5 degrees of freedom, its waist 3, and it stands at an impressive height of 1.66 meters while weighing approximately 60 kilograms. What sets Atom apart is its unique training approach. Using NVIDIA's Isaac Gym, developers apply large-scale, deep reinforcement learning and feed in precise human motion capture data adapted to Atom's physical form. Remarkably, Atom does not currently rely on visual sensors for navigation. Instead, it focuses on blind locomotion, learning to move safely and effectively without sight. This blind locomotion capability is critical for real-world deployment, where lighting, visibility, and obstacles may be unpredictable. The robot dynamically adapts to whatever environment it faces, enabling robust and reliable walking and movement. Could robots like Atom mastering dynamic walking without vision, become the perfect partners for unpredictable and complex real-world tasks? Beijing's World Humanoid Robot Sports Games. While robotics technology races ahead in labs and factories, China is also pioneering a new frontier, blending technology with athleticism and public spectacle. The upcoming World Humanoid Robot Sports Games, set to take place in Beijing's iconic Olympic venues, the Bird's Nest Stadium and the Ice Ribbon Arena, promises to be a groundbreaking event that showcases the very best of humanoid robotics. This event is not a mere exhibition, but a fiercely competitive arena where robots will compete in 11 different sports disciplines. These range from track and field races, where robots will sprint, jog, and test endurance, to highly technical fields like gymnastics, which demand impeccable balance, flexibility, and precision. Even football, soccer matches will be contested, pushing robots to demonstrate coordination, strategy, and teamwork. The significance of the event goes far beyond entertainment. It represents a strategic move to accelerate the development of robotics by placing machines under the pressure and unpredictability of real-world dynamic competition. Sports push robots to master skills such as rapid decision-making, balance during complex maneuvers, recovery from falls, and synchronization with teammates, all vital for practical applications outside the stadium. This is the second major robot sports event in China this year. In April, a humanoid half-marathon captivated audiences as 20 robots lined up to run continuously for nearly 2 hours and 40 minutes. The winning robot, Kang Ultra, not only finished first, but set new benchmarks for mechanical endurance and stability. Such endurance challenges demonstrate how far robotic hardware and software have come in terms of power management, heat dissipation, and real-time control. Experts see these competitive events as invaluable testing grounds, accelerating innovations in hardware resilience, AI decision-making, and sensory integration. Robots face dynamic terrain, crowd noise, unexpected obstacles, and even strategic interference, conditions that mirror real-life challenges robots must master in fields like search and rescue, healthcare, and manufacturing. Moreover, the World Humanoid Robot Sports Games will provide extensive data for improving motion algorithms and mechanical designs. Each competition round is meticulously recorded and analyzed by developers and scientists, revealing weaknesses and opportunities for advancement. The result is a virtuous cycle where public competition feeds directly into technological breakthroughs. As humanoid robots compete and push their limits on the world stage, will this high-pressure arena accelerate the day when robots become everyday teammates and helpers? The four-legged firefighter. While humanoid robots showcase grace and precision, four-legged robots like Unitree's B2 dog redefine what machines can do in dangerous environments. The B2 firefighting robot dog represents a bold stride toward robotics, actively saving human lives in conditions too perilous for firefighters. This version of the B2 robot dog has been engineered with enhanced agility and strength, allowing it to traverse rubble, stairs, and uneven ground with remarkable ease. Its joints have been reinforced by 170% compared to the standard model, enabling it to climb obstacles up to 15 inches and ascend steep stairs at angles reaching 45 degrees. Equipped with a powerful water cannon that can spray foam nearly 200 feet away at 40 liters per second, the B2 dog can attack fires from safe distances where humans would be at severe risk. This firefighting capacity is paired with an advanced sensor suite that includes live video streaming, LiDAR scanning for real-time 3D mapping, and wireless communication systems transmitting vital information to remote human operators. Beyond its fire suppression role, the B2 robot dog carries life-saving features like a built-in cooling sprinkler system to protect its sensitive electronics from heat damage. It also boasts swappable battery packs that can be replaced without compromising waterproof seals, enabling continuous operation during prolonged emergency missions. The B2 is designed for zero-visibility scenarios, such as smoke-filled rooms or toxic environments where human presence could be fatal. It can map interiors, detect fire hotspots, navigate debris, and even carry small equipment or rescue tools. Its ability to operate independently or in coordination with human teams makes it a versatile and invaluable asset in disaster zones. This technology is an early glimpse into a future where robot firefighters complement human efforts, reducing casualties and increasing efficiency in emergency responses. The integration of mobility, fire suppression, sensory intelligence, and communication transforms the B2 into a multi-purpose platform poised to revolutionize firefighting. Could the B2 firefighting dog soon become a frontline hero in emergency scenarios, transforming how we fight fires and protect communities? Lenovo's leap into humanoid robotics. Not to be outdone by Unitree, tech giant Lenovo has boldly entered the humanoid robotics arena with its own creation, the Liang No One. Unveiled at Lenovo's Tech World event in Shanghai, this robot represents a fusion of cutting-edge AI, robotics engineering, and real-time data integration, signaling Lenovo's serious commitment to shaping the future of human-robot interaction. The Liang No One is more than just a walking machine. At its debut, it captivated the audience by performing a Tai Chi routine live on stage, a striking display of fluidity, balance, and controlled movement that few robots have managed to replicate convincingly. This artistic demonstration was paired with a Q&A session, where the robot answered real-time business questions, pulling data dynamically from Lenovo's vast digital ecosystem. Powered by a hybrid intelligent architecture that seamlessly blends device-level processing, edge computing, and cloud services, Liang No One can understand and interact naturally across devices. This system allows it to access both public and private knowledge bases, adapt to changing environments, and perform complex autonomous tasks. Security and privacy are at the forefront of Lenovo's design, with secure data handling protocols and layered AI frameworks, ensuring that personal and corporate information remains protected. The robot's ability to work autonomously while maintaining secure communications makes it ideal for sensitive environments, such as healthcare and elder care. Indeed, Lenovo is not merely showcasing a technological curiosity. They are preparing the Liang No One for real-world applications. Plans are underway to deploy these humanoid robots in hospitals, nursing homes, and other care environments where they can assist with patient monitoring, basic caregiving tasks, and interactive companionship. The timing is strategic. By August, Lenovo will showcase Liang No One competing in the World Humanoid Robot Sports Games in Beijing, further demonstrating its agility and responsiveness under pressure. This public exposure not only raises awareness, but also allows Lenovo to gather critical performance data to refine future iterations. In a broader context, Lenovo's entrance highlights the convergence of traditional IT powerhouses with robotics innovation, blending software, hardware, and cloud capabilities to deliver versatile, intelligent machines. It raises intriguing questions about how these giants will compete or collaborate in a rapidly evolving market. With Lenovo's blend of AI sophistication and real-world applications, could Liang No One redefine how robots fit into our daily lives and workplaces? PND Botics and the revolutionary Atom. Among the rising stars in China's robotics scene is PND Botics and their humanoid robot named Atom. What makes Atom truly exceptional is its walking capability. Not just moving forward, but walking like a human with adaptive stride, dynamic balance, and natural pace modulation across uneven and unpredictable terrain. This human-like locomotion is powered by PND Botics' proprietary reinforcement learning combined with imitation learning. Atom's development began in mid-2023 and has seen continuous upgrades, especially in its legs and feet, which are reinforced for durability. Its actuators are modular, allowing for easy maintenance and adaptability to a variety of real-world challenges. Atom's control system runs on a full-stack platform powered by an Intel i7 processor, enabling real-time decision-making and precise full-body motion architecture. Its legs boast 25 force-controlled actuators, delivering up to 360 Newton-meters of torque. The robot's waist has 3 degrees of freedom, arms have 5, and it stands 1.66 meters tall, weighing about 60 kilograms. What sets Atom apart from many robots is its ability to learn and adapt dynamically. Trained with NVIDIA's Isaac Gym, a powerful deep reinforcement learning framework, Atom has absorbed thousands of simulated human movements captured by motion capture systems. This data was fine-tuned and adapted to its unique body mechanics, allowing Atom to replicate complex, human-like actions without relying on vision. Focusing primarily on blind locomotion, Atom can adjust to varying terrains and obstacles even without visual inputs, a major leap forward in robot autonomy. This capacity for dynamic adaptation, transitioning from simulation environments to real-world situations, addresses one of the most persistent challenges in humanoid robotics. Atom's walking system means it can perform tasks ranging from industrial inspections in difficult locations to search and rescue in debris-filled disaster zones. Its ability to maintain balance, recover from perturbations, and navigate uneven surfaces opens the door for practical deployment beyond controlled lab environments. With ongoing development, Atom aims to incorporate vision and advanced sensor fusion, further enhancing its situational awareness and task execution abilities. This robot symbolizes the cutting edge of humanoid mobility, combining strength, flexibility, and intelligence in one package. As Atom continues mastering human-like walking, could it soon blur the line between robot and human in movement and task execution? Rise of robot sports. In a spectacular fusion of technology and competition, Beijing is gearing up to host the World Humanoid Robot Sports Games this August. This ambitious event, staged within actual Olympic venues, such as the iconic Bird's Nest and Ice Ribbon arenas, is more than just a robotics showcase. It is a proving ground for the next generation of humanoid machines. Robots from around the globe will compete in 11 events modeled after human sports, including track and field, soccer, gymnastics, and more. These competitions are designed not only to entertain, but to push the limits of robot design, agility, and control algorithms under high-stakes conditions. The games bring together leading robotics companies, engineers, and sports professionals who collaborate closely to create challenges that replicate the complex dynamics of human athletics. The goal is to stress-test mechanical structures and motion software, revealing how well these machines perform outside of controlled lab environments. This competition is the second major robot sports event hosted in China this year, following a humanoid half-marathon in April, where 20 robots ran for nearly 3 hours straight. The winner, the Qiang Kong Ultra, set new standards for endurance, stability, and safety, proving these machines can handle prolonged, complex physical exertion. By simulating real athletic stress and unpredictability, these events accelerate the development of robots capable of navigating the chaotic and ever-changing real world, key to their future in disaster response, caregiving, and industrial tasks. As humanoid robots sprint, leap, and kick their way to victory in Beijing, could this be the start of a new era where robots compete and cooperate alongside humans? Future visions. With Unitree's G1 and PND Botics, Atom setting new standards in humanoid robotics, the horizon for intelligent machines looks thrillingly expansive. But what's next for the industry? Experts suggest a multi-dimensional evolution where robots become more than just mimics of human motion. They become collaborators, decision-makers, and even companions. One key frontier is enhancing robot autonomy while ensuring safety and ethical integration into society. Adaptive motion optimization like AMO will continue evolving, paired with breakthroughs in machine perception, emotional intelligence, and language understanding, allowing robots to interact naturally and empathetically with humans. Modularity will also play a huge role. Future robots might feature interchangeable limbs and sensor packages customized for specific tasks, whether medical assistance, disaster recovery, or household chores, making them versatile tools in diverse environments. Energy efficiency is another critical focus. Advances in lightweight materials, battery technology, and energy recovery systems could enable robots to operate longer and perform more power-intensive tasks without frequent recharging. Integration with smart homes and cities will further embed robots into everyday life. Imagine robots coordinating with IoT devices to manage your home, optimize energy use, or provide instant assistance in emergencies. This seamless connectivity promises unprecedented convenience and safety. Meanwhile, regulatory frameworks will evolve to address concerns about privacy, liability, and employment disruption. Transparent AI, robust cybersecurity measures, and ongoing public dialogue will be essential to foster trust and responsible innovation. Beyond the practical, the aesthetics and personality of robots will gain importance. Designers are exploring how robots can exhibit charisma, adapt their behavior to individual preferences, and even engage in creative pursuits, blurring the line between machine and companion. As robots gain brains, hearts, and even personalities, are we ready to share our world with intelligent companions? How robots like Unitree's G1 and Atom are changing industries today? The leap from laboratory prototypes to real-world applications marks a pivotal moment in robotics, and Unitree's G1 and PND Botics Atom are leading the charge. These robots are not just technological marvels, but practical solutions beginning to transform various industries, hinting at a near future where humanoid robots become commonplace workers and assistants. In manufacturing and logistics, these robots excel in repetitive, physically demanding, or hazardous tasks. Their enhanced mobility and dexterity enable them to navigate complex factory floors, handle fragile objects, and collaborate safely with human co-workers. Unlike traditional industrial robots confined to fixed stations, G1 and Atom's ability to adapt to unstructured environments significantly broadens their usefulness. Healthcare and elder care sectors stand to benefit immensely. Robots with the capability to assist with patient monitoring, medication delivery, and even physical support can address shortages of human caregivers and improve patient outcomes. The nuanced movements enabled by adaptive motion optimization allow robots to perform delicate tasks like helping patients with mobility challenges or safely navigating crowded hospital corridors. In disaster response, robots equipped with advanced sensors and resilient designs can enter dangerous zones inaccessible to humans. Whether inspecting structural damage, searching for survivors, or delivering critical supplies, these machines provide invaluable support to emergency teams while minimizing risk to human life. Beyond industrial uses, there is growing interest in deploying humanoid robots in education, hospitality, and customer service. Their human-like form and behavior foster natural interactions, helping break down barriers between machines and people. Imagine robots serving as tutors, hotel concierges, or guides in museums, enhancing experiences while performing mundane tasks efficiently. Yet, integrating these robots into existing workflows demands thoughtful planning. Human workers will need training to collaborate effectively with their robotic counterparts. Companies must address ethical and privacy concerns, ensuring data security and respect for human dignity. As G1 and Atom step out of the lab and into factories, hospitals, and schools, how will their presence reshape the way we live and work? The human side of robotics. Public perception of humanoid robots varies widely, from awe and excitement to fear and skepticism. Many people are fascinated by the prospect of robots assisting with daily life, imagining freed time and enhanced safety. Others worry about loss of privacy, autonomy, and the blurring line between humans and machines. One significant ethical challenge is ensuring that robots respect human rights and dignity. Developers and policymakers must define boundaries, such as prohibiting robots from making autonomous decisions in critical areas without human oversight, especially in healthcare or law enforcement contexts. The possibility of job displacement fuels concern and debate. While robots can handle repetitive or dangerous jobs, they may also disrupt employment in industries dependent on manual labor. Society faces the task of preparing for this shift, ensuring fair transitions and harnessing robotics for inclusive growth. Data security and privacy are paramount. Humanoid robots often collect sensitive information through cameras, microphones, and sensors. Protecting this data against misuse or breaches requires rigorous safeguards and transparent policies. Psychological impacts are also being studied. Interactions with robots may affect human social behavior and emotional health. Questions about attachment, dependency, and even loneliness arise as robots take on caregiving or companionship roles. Educational initiatives and public engagement can help demystify robotics and build trust. Encouraging dialogue between technologists, ethicists, and communities fosters responsible innovation aligned with human values. Finally, the question of legal accountability looms. If a robot causes harm, who is responsible? The manufacturer, the operator, or the robot itself? Developing legal frameworks to address such scenarios is an urgent priority as humanoid robots become more autonomous. Thanks for watching. If you enjoyed this deep dive into Unitree's groundbreaking robots, check out our next video for more tech surprises. Don't forget to comment below with what you'd want a robot to do for you.